Hi, I'm Elleni and in this box set video, you'll uncover the sophisticated capabilities of ArcGIS Velocity for visualizing and analyzing IoT data. The need for real-time data is increasing at an exponential rate. It's also estimated that roughly 80% of sensor data has a location component, which means there's a growing variety of geospatial use cases in the Internet of Things. Businesses of all types want to monitor, manage, and optimize their operations, whether that means managing a fleet of vehicles, keeping personnel safe out in the field, or improving response times to emergency events. In the utility space, there's SCADA integration that involves placing sensors on a network to monitor its health and real-time status. In transportation, there's an increasing number of roadway sensor deployments to bring in data from connected vehicles. So how can ArcGIS Velocity support this growing need for real-time data? ArcGIS Velocity extends Esri's geospatial cloud with real-time and big data analytics functionality. It provides a wide range of capabilities for ingesting and working with observation and sensor data. And you do this by configuring out-of-the-box connectors to bring in data from IoT platforms and third-party APIs. It's also an end-to-end system for analysis, supporting analyzing data in real time, in near real time with scheduling, and over time. And you can take immediate action as a result of your analysis, such as sending alerts and notifications or triggering downstream processes. As a product, ArcGIS Velocity is software as a service. One of the key characteristics here is its scalability and resiliency. Under the hood, it runs on a Kubernetes container-driven architecture. This enables it to scale because compute can be distributed across parallel tasks, and to be more resilient because tasks that encounter issues can restart and pick up from where they left off. And it's fully managed by Esri, which takes away the complexity of configuring and maintaining a suite of on-premise servers. So let's consider how you can use ArcGIS Velocity to ingest, analyze, alert, and act on your real-time data coming from your IoT systems. We also want to consider how ArcGIS Velocity fits into your wider ArcGIS system. And for this scenario, I want to consider how ArcGIS Velocity might support a water utility. Let's start with ingesting data. Feeds are the first step in leveraging real-time data. There's thousands of sensors on the market today, and being able to connect to that data and use it often involves vendor-specific data applications that are siloed, or requires custom-built solutions to read it and integrate it with enterprise systems. Configuring feeds in Velocity, however, is an easy-to-use guided workflow that lets you directly and seamlessly connect to your real-time data systems. They automatically derive the schema of the data and allow you to revise your data model on the fly. And you simply add them to your maps to immediately see the real-time information and maybe combine it with other data. For my water utility, this is both system integration and situational awareness configured in minutes without writing a single line of code. So what does that seamless process of ingesting data look like? Here you can see I'm accessing my ArcGIS Velocity application inside my web browser, and I have access to all the tools I need to get started. On my homepage, I can see my recent feeds, and for my water utility, I also have access to the guided workflows that help me bring in my real-time data. For IoT systems, ArcGIS Velocity allows the ingestion of real-time data from leading cloud platforms such as Azure Event Hub and AWS IoT. For my water utility, I want to ingest a live feed for my water tanker locations, which deliver water to customers whilst they may be temporarily off supply from an outage. To do this, I simply enter the URL endpoint for my water tanker locations. ArcGIS Velocity instantly gets to work checking that it understands the data schema, and once I'm happy it's all correct, I can set my location, date, and any tracking data to ensure that those water tankers are captured correctly. As you can see, configuring ArcGIS Velocity for your real-time data is quick and easy, and I can then specify how often I want to run this feed and collect new data from my IoT system. For many feeds, this is instant real time, but it could also poll an API at a certain time of day or at a specified time interval, such as every 10 seconds. So how can we then start to use this real-time data for analysis? Real-time analytics provide geospatial and statistical analysis tools to your tracking and sensor workflows. Instead of requiring custom-built applications to analyze your IoT data, any end user can assemble an end-to-end workflow to detect incidents and capture information. Real-time analytics process each message from a feed continuously as they arrive, and they can also leverage static data sources as well to serve as geofences or enrichment data. You can combine different tools together in a workflow to ask any number of questions and then associate different output behaviors with each one. In some cases, you might want to store data, whereas in others, you might send alerts or a command to a third-party system. Real-time analytics are useful for when your decision timeline is operational, when you need to know about something and take action immediately. Let's take a look at how you can configure a real-time analytic. In the ArcGIS Velocity app, I'm able to create my new real-time analytic from an existing feed. In this example, I'm going to create a simple analytic to analyze sensor data coming from SCADA devices on a water network. Let's go ahead and create that analytic item. I can then start to view my analytical workflow in a model view. Some of you may be really familiar with this analytical model view in that it's very similar to Model Builder in ArcGIS Pro. And it works in a very similar way, where I have access to geospatial, statistical, and data enrichment tools that help me to analyze and transform my data in different ways. For example, I might want to filter my sensor data from my network to only show where a sensor or SCADA device has triggered an alarm I'm interested in. For this, I can configure a simple arcade expression. For this scenario, I want to filter for only high pressure alarms. This makes it really easy to separate the noise from your IoT systems from the data you're really interested in for your operations. Once I'm happy I've configured my filter expression correctly, I can start to think about how I output this data to the rest of my organization. I'm actually going to create a feature layer that can then be shared through apps or dashboards. I have options to keep only the latest data or to keep adding the latest data so I can view changes over time. I can also choose a data retention period, meaning I can tell the system to only retain information that's a day, week, or months old and archive anything older than this. Once I give the output layer a name, I am then able to chain together the filter to the feature layer in my real-time analytic model. I can hit save and then start the process of the real-time analytic. Here, I've been able to configure a slightly more complex analytic that will automatically detect incidents from those sensors on my water network and then take action on them in real time. In this scenario, the real-time analytic automates a process to evaluate the proximity of external forces to my sensor alarms, including mains replacement works, road construction, and flooding areas. When an external force is found to be in close proximity, the analytic then triggers an action. This might be sending an automated text message to the closest tanker so they can get to impacted customers quickly. As well as sending automated alerts, ArcGIS Velocity can send data back to your IoT systems or other data sets in your ArcGIS environment. That might include sending a follow-up notice to a work order management system or sending information to public outage maps. So how can I then share the results of my analytic to my organization? I've chosen a dashboard as an operational tool for my water utility so they can better respond to the outages on their network. My ArcGIS Velocity analytic is feeding through my alarm sensor data in real time, but it also identified a few areas where sensor alarms came into close proximity to external factors. Where a high pressure alarm was detected, the analytic found coincident mains replacement works. As a result, the mains replacement team operating in this area were notified through email to inspect and check the network is still running smoothly once their work is complete. In this area, a low pressure alarm was detected in close proximity to a flooding alert. Heavy rains may have caused damage to the network from shifting land and soil and caused a leak that has knocked customers off supply. As a result, the closest tanker to the alarm was notified through SMS to get to the impacted area as quickly as possible, whilst being aware of any health and safety issues that might still be present. As I brought in my real-time tanker feed into ArcGIS Velocity, I can even see the closest tanker in real time on my map and see how far away they are to respond. For a sensor that appears to have gone silent, I can see that road construction is also taking place near my sensor and may have caused damage. A technician received a text message to go and inspect the sensor as soon as possible. For more complex workflows, big data in ArcGIS Velocity can be used to analyze data that you store over time. Big data analytics are useful for when your decision timelines are tactical, i.e., you want to access historic sensor data on a utility or telecom network to inform future investment every month, quarter, or on an annual basis. Much like real-time analytics, you can stitch together different tools in an overall automated process and create multiple information products at the same time and on the same data. This can reduce the need to configure and maintain on-premise data centers and keep them optimized. You can run analysis either on feature layers with data you have stored over time or cloud big data stores that are fed from other organizational systems. The results of your big data analytics, just as we saw with real time, can then be shared with multiple teams and departments automatically to ensure that everyone has the latest authoritative dataset that's been analysed on a standardised methodology. This is really important for organisations who might need to submit data to regulators, and so if you can show the same analysis is being done each time, there is more trust and confidence in the quality of your data reports. You may be wondering, how can I get started with ArcGIS Velocity and find out more? There's a wealth of useful information available to you on Esri UK's website for ArcGIS Velocity, including documentation, blogs, videos, and much more. If you're wondering how ArcGIS Velocity might be used in your organisation to transform how you operate with IoT and real-time data, please don't hesitate to get in touch.